Okay, today we're going to have a look at the remainder and the factor theorems. Now, two of the most important applications and things that we use when we polynomial divide are the remainder and the factor theorems. Now, the purpose of polynomial divisions, one of the main purposes, is to quickly factorize a polynomial to get the x-intercepts of the polynomial so we then can graph it on a Cartesian plane. Now, in the previous video, we looked at polynomial division and dividing polynomials, but it raises the question, if I want to divide these polynomials to get my x-intercepts, I have to know the thing to divide the polynomial by. So, for example, in this previous lesson, in this previous lesson here, we divided x cubed plus x squared minus 4x plus 3 by x minus 1. But if I wanted to find the x-intercepts of this function, how would I know to divide by x minus 1? And the answer is we wouldn't really. The remainder and factor theorems help us pick what it is appropriate to divide by. So the remainder theorem states that if I am dividing a polynomial by x minus a, the remainder is p of a. So for example, when I'm dividing by x minus 3, the remainder is p of 3. So I'm substituting into the equation that value of a. Now the most important application of the remainder theorem is the factor theorem. So if you substitute in that a and you get 0, it spits out 0, that means that x minus a is a factor of that function, of that polynomial. That's important because when we polynomial divide, instead of getting, say, 1 or 5 as our answer down here, we will get 0. And that means there's going to be no remainder plussed on the end, which means we can actually completely factorize our polynomial. And sometimes we might have to polynomial divide 2 or 3 times to fully factorize it. So example 1 says find the remainder when p of x is equal to x cubed minus 5x squared minus x plus 4 is divided by that. So we're going to substitute the opposite of what you think. We're not substituting in minus 2. We're going to find p of 2. And that is 2 cubed minus 5 times 2 squared minus 2 plus 4. Type that in. 2 cubed minus 5 times 2 squared is 4 minus 2 plus 4. We get minus 10. So the remainder is minus 10. Part B, remember we're substituting the opposite of what you think. So not 1, but minus 1 equals minus 1 cubed minus 5 times minus 1 squared minus minus 1 plus 4. Keeping in mind that when you substitute a negative number into your calculator, you need to put the negative number in brackets or your calculator won't know to get rid of the negative. If you do that, you get minus 1. So the remainder is minus 1. Okay, decide whether each of the following is a factor of that function. P of x is x cubed plus x squared minus 3x minus 6. So again, let's substitute in p of minus 1, not plus 1. It's the opposite of what you think, p of minus 1. So minus 1 cubed plus minus 1 squared minus 3 times minus 1 minus 6. I think the answer is going to be, yes, I think it will be, but let's check. X cubed plus x squared minus 3x minus 6 equals, oh no, minus 3, it's not. So therefore, no, it's not a factor. Okay, let's have a go. We're going to substitute in 2 this time. So p of 2 is 2 cubed plus 2 squared minus 3 times 2 minus 6. That does get me 0, so therefore, yes, it is. That means when you polynomial divide x cubed plus x squared minus 3x minus 6 by x minus 2, the remainder will be 0. Okay. Find the value of k. Now one of these exact questions usually will always be in a Year 11 Extension 1 preliminary exam. So you're really setting yourself up by learning this content for next year. So we're finding value of k such that this function, when we do this division, has a remainder of 5. In other words, when I divide that by that, I get 5 as a remainder. In other words, if p of x is equal to x cubed minus x squared plus 2x plus k, if I find p of 1, the answer should be 5. 1 cubed plus 1 squared, or minus 1 squared, plus 2 times 1 plus k equals 5. Let's add up all those numbers. 1 minus 1 plus 2 times 1 is 2. So 2 plus k equals 5. Subtract that little 2 over, and we've got k is 3. So the answer is k is 3. All right, thank you.